And we're back. Subelement E3, radio wave propagation. 3 exam questions come out of the 3 groups in this subelement. E3A is electromagnetic waves and specialized propagation, Earth-Moon-Earth communications, meteor scatter, microwave, tropospheric, and scatter propagation, auroral propagation, daily variations of ionospheric propagation, and circular polarization. E3A01, what is the approximate maximum separation measured along the surface of the Earth between 2 stations communicating by EME? Answer is D, 12,000 miles if the moon is visible by both stations. E3A02, what characterizes libration fading of an EME signal? B, a fluttery, irregular fading. E3A03, when scheduling EME contacts, which of these conditions will generally result in the least path loss? A, when the moon is at full perigee. E3A04, in what direction does an electromagnetic wave travel? Answer is D, it travels at a right angle to the electric and magnetic fields. E3A05, how are the component fields of an electromagnetic wave oriented? And it is C, they are at right angles. E3A06, what should be done to continue a long-distance contact when the MUF for that path decreases due to darkness? B, switch to a lower frequency HF band. E3A07, atmospheric ducts capable of propagating microwave signals often form over what geographic feature? C, large bodies of water. E3A08, when a meteor strikes the Earth's atmosphere, a linear ionized region is formed at what region of the ionosphere? That's A, the E region. E3A09, which of the following frequency ranges is most suited for meteor scatter communications? C, 28 MHz to 148 MHz. E3A10, what determines the speed of electromagnetic waves through a medium? D, the index of refraction. E3A11, what is a typical range for ionospheric duct propagation of microwave signals? It's B, 100 miles to 300 miles. E3A12, what is most likely to result in auroral propagation? C, severe magnetic storms. E3A13, which of these emission modes is best for auroral propagation? A, CW. E3A14, what are circularly polarized electromagnetic waves? B, waves with rotating electric and magnetic fields. E3B is covering trans-equatorial propagation, long path propagation, ordinary and extraordinary waves, Chordhob, sporadic E mechanisms, ground wave propagation. E3B01 says, where is trans-equatorial propagation most likely to occur? Answer is A, between points separated by 2,000 miles to 3,000 miles over a path perpendicular to the geomagnetic equator. E3B02, what is the approximate maximum range for signals using trans-equatorial propagation? C, 5,000. E3B03, at what time of day is trans-equatorial propagation most likely to occur? That's C, afternoon or early evening. E3B04, what are extraordinary and ordinary waves? B, independently propagating elliptically polarized waves created in the ionosphere. E3B05, which of the following paths is most likely to support long-distance propagation on 160 meters? D, a path entirely in darkness. E3B06, on which of the following amateur bands is long path propagation most frequent? B, 40 meters and 20 meters. E3B07, what effect does lowering a signal's transmitted elevation angle have on ionospheric HF skip propagation? C, the distance covered by each hop increases. E3B08, how does the maximum range of ground wave propagation change when the signal frequency is increased? C. It increases. E3B09, at what time of year is sporadic E-propagation most likely to occur? A. Around the solstices, especially the summer solstice. E3B10, what is the effect of chortle hop propagation? A. The signal experiences less loss compared to multi-hop propagation, which uses Earth as a reflector. E3B11, at what time of day is sporadic E-propagation most likely to occur? D. Between sunrise and sunset. E3B12, what is chortle hop propagation? B. Successive ionospheric refractions without an intermediate reflection from the ground. E3B13, what type of polarization is supported by ground wave propagation? A. Vertical. E3C, propagation prediction and reporting, radio horizon, effects of space weather phenomena. E3C01, what is the cause of short-term radio blackouts? And that's D, solar flares. E3C02, what is indicated by a rising A index or K index? A, increasing disturbance of the geomagnetic field. E3C03, which of the following signal paths is most likely to experience high levels of absorption when the A index or K index is elevated? It's B, through the auroral oval. E3C04, what does the value of BZ, B sub Z, represent? C, north-south strength of the interplanetary magnetic field. E3C05, what orientation of B sub Z increases the likelihood that charged particles from the sun will cause disturbed conditions? A, southward. E3C06, how does the VHF-UHF radio horizon compare to the geographic horizon? A, it is approximately 15% farther. E3C07, which of the following indicates the greatest solar flare intensity? D, Class X. E3C08, which of the following is the space weather term for an extreme geomagnetic storm? D, G5. E3C09, what type of data is reported by amateur radio propagation reporting networks? That's D, digital mode and CW signals. E3C10, what does the 304A solar parameter measure? That's B, UV emissions at 304 angstroms correlated to the solar flux index. E3C11, what does the VOACAP software model? That's C, HF propagation. E3C12, which of the following is indicated by a sudden rise in radio background noise across a large portion of the HF spectrum? B, coronal mass ejection impact, or a solar flare has occurred. And that'll conclude subelement E3. Thank you for joining us, and hopefully you'll join us for subelement E4 later.